How do I close this guy? There we go. Okay, yeah, as Tracy said, my name is Mark Houghtlin, and I am a member of IBM. Just a little background on myself. I've always been in the application performance and optimization space for pretty much most of my career. I have about 28 years in at IBM now, so I've seen a lot of technology come and go. And so the purpose of this white paper, it's really a white paper supplement, and it's a supplement to an original white paper on migrating applications to the cloud. And specific to that white paper was looking at workloads and the fit of a workload for a particular targeted cloud environment. And one of the elements that you need to look at in regards to fit is really assessing the performance and response time requirements. It's just a piece of it. There's lots of things that need to be assessed, but the white paper supplement is specific just to how you would go about assessing the performance and response time requirements. So with that, the white paper is really set up into two different sections. The first section is in regard to how you might go about assessing performance and response time requirements for a specific workload, and how by doing that it might help you identify additional workloads that may be a fit for the cloud environment, or on the other hand, it could also identify workloads that are not such a good fit because of the impact to the response time that might occur. So that's really the first part of the white paper. I would say, my experience at IBM has been mostly with large enterprise clients. My experience to date has been that these large enterprise clients have been slower to adopt cloud for various reasons, compliance, regulatory compliance and security concerns being at the top of the list. So a lot of this initial part of the white paper is more geared towards those type of clients, not your more, your SMB type client, as well as it's geared towards, someone who's migrating an existing application to the cloud versus someone who's developing an application on the cloud or born on the cloud. So that's the first part of the paper. The second part of the paper talks a little bit about application performance technology and how that technology can be used to help better manage the application lifecycle of the application in the cloud, from a performance management perspective. Okay, so with that, I'm going to move on. I'll go to my next page.
Hey, Mark, it's Tracy. I was just going to suggest you might want to move to full screen if you can.
Let me do that. I'm a little challenged here, so let's see.
Oh, no problem.
Screen there we go. Let's try that. Is that better?
That's perfect.
Okay. Okay, so just a little context before we get into, the real purpose of the white paper. I mean, obviously before you really start looking at the non-functional requirements of a workload, there's going to be some upfront work prior to that. You're obviously going to have a cloud strategy, and based on that cloud strategy, you're going to be choosing what your target cloud environment is. And then you're going to be assessing what type of workloads may or may not be a good fit for cloud. So the context is that we have our cloud strategy in place. We've determined the target clouds that make sense for our organization, and we've identified some workloads that, at least from a functional standpoint, fit our target cloud environment. I'm trying to, okay. There we go. All right, having a little bit of difficulty paging down. So what becomes important after you've met at least your functional requirements is now you have to take a look at some of your non-functional requirements. And again, if this is for an application that's just going to be developed in a cloud environment, then this type of work isn't necessarily, required. So again, this is more for your enterprise type client. And really, where it probably comes into play more often than not would be in a hybrid type deployment. where pieces of the workload are going to still reside on-premise, and other pieces or components of the workload would reside, in the cloud. And so one of the key areas that you're going to want to address in there is what the performance and, response time requirements are. And part of my background has been, for the last 10 years, I've been migrating workloads, from a legacy managed services environment type perspective, helping my clients migrate applications to a managed type facility. So this isn't new to me. Cloud's just a little different component to it. But I've always specialized in looking at, how to migrate that application to the new environment. If that application needs to be split up due to shared resources and that sort of thing, what's going to be the impact during and after the migration? And it's always been specific to response time. Okay, and so one of the key things that's going to could potentially impact response time would be network latency. And let me give you a good example of one of the questions and concerns that keeps coming up with my clients is, for example, they're interested in having their systems of engagement in the cloud, but the systems of record, for whatever reason, security, regulatory compliance, the systems of record needs to remain on-premise. And so that creates a physical separation and introduces network latency. And potentially that network latency could cause an impact to the response time. So the concern becomes, what is that impact going to be? And that's where that's where you really want to focus in on, figuring out what that impact is going to be. And you want to do this obviously prior to migrating any components of that workload to the cloud, because you want your cloud migration obviously to be successful, and you don't want something like this to upend that. So specifically, what I'm talking about is looking at taking a really much closer look at the application transaction itself. What we found out, how we go about doing it in IBM is in order to understand the response time requirements completely, we need to look at the end-to-end transaction and the flow of that end-to-end transaction. And looking at this slide here, what you can see is by understanding the end-to-end flow of the transaction, you can see in today's environment, a transaction could start out as a synchronous transaction, which is response time sensitive and may potentially be impacted by increases in latency. But on the back end here, the transaction becomes asynchronous in nature. And because it becomes asynchronous in nature, it's way less likely to be impacted by an increase in latency. So the example here would be that the front-end piece of this transaction, the synchronous component, is running in the cloud, and possibly the back-end piece of it is running on-premise. But since the back-end piece is asynchronous in nature, that separation and that additional latency is not going to be of concern. So these are the type of things that you can find out by digging deeper into the non-functional requirements. Another example would be a lot of at least some of the workload analysis or workload fit analysis assessments that I have seen concentrate from a qualitative perspective. They concentrate on just looking at the number of connection points or a number of dependencies the workload has. So if I were to move this workload, how many dependencies does it have on other applications, on shared resources, and that sort of thing? And typically the more connections or dependencies the workload has, then from a non-functional standpoint, potentially it's not as good of a fit for cloud. And but by understanding the true nature of the workload from an end-to-end perspective better, you can really quantify that and understand that better, and you may find out that on further analysis that it is more of a fit for cloud than you thought. And so in doing that, we do something that we call business transaction mapping, and we found that this is very successful for us. And what it means is it's understanding the transaction from when it's initiated and following it all the way through, through all the front-end systems, to the middleware environment, and to the back-end environment and back, and understanding the true nature of that transaction. And of course, that transaction could represent, the workload, or could represent multiple workloads. And we go about doing that. There's different approaches that you can take to do that. We take a consultative approach, and we can augment that with tools. And there's also tools out there that you can install in a production environment that can actually map transactions end to end, and they can actually baseline the performance of that transaction. And so they can help identify all the different components that you need to be concerned about if you were to migrate it to the cloud. So just one second, what I want to do is I'm going to jump out of presentation mode, and I want to show you an example of what I'm talking about. So just give me 1 second. And I'm going to put up a Visio diagram. And let me make that bigger. And let's see. We go into full screen mode. Okay, hopefully you guys can see a diagram that I have up right now. And so what I'm talking about when I talk about doing an end-to-end perspective of the transaction, we do this process called business transaction mapping. And what you can see here is across the top, we've identified the end users of the application. And in this case, this is an example of a ticketing, airline ticket workload for agents. And so they're booking a ticket, and so each one of the business functions listed are part of the workload in order to book a ticket. And you can see that underneath each one of the business functions that are identified is the underlying infrastructure that supports each one of those business functions. And that helps us identify what components must be considered if we were to migrate this workload or pieces of this workload to the cloud. And it also helps us identify where the risk areas would be if we were to migrate this workload to the cloud. And it tells us, the characteristics of the workload, how the workload is going to interact with the network, what protocols it's going to use, how much data is being moved, and those sort of things. So it really helps us focus in on how good of a fit it is from a performance and response time perspective to move to the cloud. I'm going to pop back out of that mode and go back to the presentation. Okay. So a few examples that I have now, and you'll find examples in the white paper as well. And so really what you want to do is in some cases, once you've understood the end-to-end flow of the transaction, you understand what components may or may not be separated, what's going to remain on-premise, what's going to go to the cloud. You can then do a more deeper dive focus or do a quantitative analysis. And using tools, and some of the tools are listed in the white paper, those tools will allow you to baseline the performance of that transaction in the current environment, and then it allows you to model what the impact would be if you were to separate certain tiers. Okay. Again, another good example that I've run into is, and my experience is with SoftLayer at this point. So I have some clients who want to put elements of their workload in SoftLayer, in this case systems of engagement, but because their systems of record, because of security requirements, need to remain on site. And this is specific to Canadian clients that I've had, that I've worked with. And so their nearest SoftLayer hub is round trip close to 30 milliseconds away. So if they wanted to do that, keep the systems of a record on premise in Western Canada and have the systems of engagement in the cloud at the nearest SoftLayer hub, it's going to add 30 milliseconds of latency. And so their concern is how do I determine that impact? Was that going to impact my response time? I'm still going to be able to meet my response time requirements. And so again, what we would do there is we would do the end-to-end transaction mapping. We would then use tools to baseline how it's performing in the proposed environment. And then we would use other tools to help us model what the impact is. So if I were to add 30 milliseconds of latency between my systems of engagement and my systems of record, how is that going to impact the performance of that transaction? And you can see some examples here where it shows by adding latency how it impacts the baseline performance. You can see the columns there, baseline response time versus projected response time would be where we've introduced latency between our tiers that would be separated. And in our case, we don't make a decision for our clients. We just share this information with them, and it's really between the business teams and the application teams that would decide whether or not that impact is acceptable or not. Now, if the impact is not acceptable, well, then you have to start looking at how you're going to mitigate that. You don't want to just throw up your hands and give up then. So oftentimes doing these type of studies, you collect a lot of information in regards to the characteristics of how the application interacts with the network. And it's that interaction that that you look to mitigate. So just as you would optimize a SQL query to consume as few resources as possible and to be as efficient as possible, you also want to optimize network interaction or application network interaction. And this type study allows you to do that. It gives you enough of the characteristics of how the application is interacting with the network, and gives you some options of where you could mitigate and make that interaction more efficient, which would then decrease the impact of the network latency, and then possibly allowing you to further consider moving that workload or components of the workload to the cloud. And so you see some of the charts. They show you some of this. They show you where the time's being spent, on which tier. It also gives you an indication of if you were to mitigate, where you'd probably get the best. If most of the times are being spent at the client, well, you're probably going to get more bang for your buck mitigating at the client than at any of the other tiers. So it gives you that sort of insight. Okay, so that's the first piece of what I wanted to talk about today. And so the second piece is in regards to the APM, or Application Performance Management technology. And APM is something that has been around for a long time, but it's made leaps and bounds in its ability to really follow a transaction through from end to end and through all the logical components that support that transaction. So if you think about that, that makes it ideal technology to support a workload in the cloud and to report on the response time and the SLAs for that workload, and also to really help you optimize that workload so that you can meet your SLA. And so whereas the first part of the white paper talks more about an enterprise client and about where you're migrating an application to the cloud, APM is more for any sort of case. It certainly fits the born on the cloud environment, where in the pre-production environment, you want to optimize that workload as much as possible before you put it, into production. And it also fits, in steady state environment, being able to continue to monitor the workload and the performance of the workload, and then reporting that information, back, just to show that you're meeting your SLA. Okay, so some of the APM use cases that make sense is from a cloud migration standpoint, migrating production workloads to the cloud. APM can be used to help you, one, uncover the end-to-end components that comprise the workload. Can also help you, baseline it. And then with other tools, you can do some modeling to determine the impact if you were to move it to the cloud, if there is any impact. So that's one scenario. A second scenario would be new cloud application deployment. So you're developing a new application in the cloud environment. This is in the development and test environment. You're concerned if your response time requirements are going to be achievable. So you can use this APM technology to help you with that. So it's really going to help with, pre-production performance optimization and looking at load and scalability testing. Also helps you to establish, business-aligned service level agreements that are actually obtainable, and then, of course, can be measured and then reported back to the business. Another scenario for APM would be in release preparedness. So I have an existing cloud application, but obviously I'm going to continue throughout the life cycle of that application to make changes to it, to add new capabilities. So APM has a very strong use case for comparing changes and comparing new capabilities to how it's performing previously, and then helping you to isolate and resolve any performance problems during development and pre-production testing, and before you deploy those changes into production. And then the last scenario is around incident management. Obviously, this would be in the production environment, and these tools are great for helping isolate and resolving performance problems for cloud-based applications. And again, based on the technology, it can actually provide code-level visibility, which allows you to actually see the code that's being executed within the transaction. So if you have a delay somewhere, you can compare it to the baseline. You can identify on which tier, which component actually the delay is taking place. And in many cases, actually identify it down to the actual problem code that's inefficient, causing the performance problem. So very powerful tools. And with that, that really covers what you would find in the white paper. If you haven't read the white paper yet, you'll see the link in the PDF, and that'll take you there. And I guess with that, I'm open to take any questions.
Great, Mark. Thanks. We do have a couple questions that came in. The first question, what about security issues in the application? How do you mitigate that if the application is compromised?
Okay, so security is obviously a very important component of determining workload fit, right? And based on those security requirements, it's really going to determine whether the workload is a fit or not. So from my standpoint, when we get involved into the non-functional requirements, performance and response time, we're at the point where it's already a fit from a security standpoint. So really the elements of what this white paper is all about is just really addressing the performance and response time aspects of the workload. Understanding that there's lots of other elements that comprise whether or not it's going to be a good fit for cloud. This is just really specific to that.
Mm-hmm. And how easy is it to model the effect of a change in a network connection?
Yeah, so how easy it is really going to depend on the type of tools that you use. And the tools that I have experience with and I've been using, it can be pretty simple. You do have to be able to capture the network flows and understand, of the transaction that you actually want to model. And once you've captured those network flows, and when I say capture that, there's various type tools to use for that. Wireshark is one. There's all sorts of other tools that can be used as well. But in our case, we load those network flows into a modeling tool. And that modeling tool allows us to simulate latency between certain components or between certain tiers. And what it does is you're basically playing back that transaction with simulated network latency, and it will come back and tell you what the impact is from a end-to-end response time perspective to that transaction. And it'll tell you some indications why too, because it'll give you some insight into the characteristics and how efficient the transaction is and its interaction on the network. Packet size, average packet size, that sort of thing. How many application turns, which really has to do with, the more application turns you have, basically, the less efficient it is. And so, if you have a lot of application turns and increased latency, well, you're definitely going to increase your response time.
Mm-hmm. And Mark, we have one more question. Thank you. The question is, since performance can be so dependent on network latency, how are most cloud customers dealing with widely variable network latency latency, your Western Canadian customer? Would eliminating any public internet hops to a point-to-point connection be a cost-effective option?
Yeah, great question. So all those elements are going to come into play. So when I talk about mitigation type options, and those are the things that we have to look at, right? It's looking at where you can eliminate things. It's also looking at, again, I keep saying this, but my experience has shown that more often than not, the problems are with the applications. And developers don't typically pay a whole lot of attention to how efficiently their application is really communicating with the network resource. So we always start there and really looking at, can we make the application and network interaction more efficient? That's normally where we start. And in today's environment and technologies, you see just the way it's been architected that that's becoming less and less of a problem. It's really in the back end that we have issues these days where it's a lot more chatty. But, that's where we start. And obviously, any of the network pieces that have, latency that can go up and down, and it's not, as static, it's more dynamic, then, if you can eliminate those as much as possible, and that's going to help as well. Anything that you can do to decrease the latency. But, latency as a given it's physics-based, so it's based on, the distance. And so when we talk about network latency, we're really talking about that component of it. So no matter what, you're always going to have an element of latency based on distance because it's based on the speed of light and based on physics.
And Mark, are there some applications or middleware that are easier to identify network statistics versus others? And I promise this was the last one. It just came in. Thanks.
Yeah. So to me, that's more along the APM angle, the application performance management tools. And yeah, so those tools are in order to really get the application code visibility, most of those tools are centered around looking at technology that supports Java and .NET and maybe PHP type applications. And of course the middleware environments that support those. So usually with APM there's two elements. There's the infrastructure element that reports the metrics, on the operating system and that sort of thing by component. And then there's the piece of it that can actually track the transactions from end to end. But that's going to be more specific to the type of language that the type of application that it is, whether it's Java or .NET or PHP. So each vendor is different, but that's usually the starting point right there for if you want to get application level statistics. Most of them can provide the infrastructure type stats, but if you want those application stats and really be able to track the transaction end to end, then the starting point is Java and .NET.
Perfect. Well, thank you again for your time today, Mark. Your presentation will be posted to the Cloud Standards Customer Council website this afternoon. I'd like to invite everyone on the call to visit our site at cloud-council.org. Become a member if you're not already joined, and we'll invite you to future events. All of our white papers are posted to the Resource Hub on our site. Again, that's cloud-council.org. Thank you. Have a great day.
Thank you.